Hello. We're starting slightly late because I forgot that I was doing this today, actually. I forgot it was Friday. So, oops. So it's probably going to be at least 10 minutes before we officially start. I was going to make slides, but I forgot. Would the redistribution clause affect the ability to link the compiler as a library to use a scripting language? No, it would not affect that ability. We want people to be able to do that for sure. Yeah, I forgot. I usually don't forget, but I've had a lot going on this week, so yeah. Has a license been published? No, no. There is no specific redistribution clause yet. This is all just in response to general vague questions that I put forth a few days ago. Has anyone tweeted anything at me as bad as the exception advocacy in recent times? No, not really. Exception advocacy is pretty much the worst. Is there any concern with all the metadata that programs are easier to be hacked as you could just read out the data structures? I don't know, man. It's not that hard anyway for people to tell what's in memory. So I don't think it's that much harder, but you only really need to ship the metadata that your program needs to use. So if you don't iterate over struct members at runtime, you don't need to include that struct. We don't provide full mechanisms for that yet, but we will. So, it'll be choice that you have. All right, with these 10 minutes, I'm going to get my thoughts in order about libraries rather than answering questions out of chat. So you guys can talk to each other for a little bit while I put together my notes. Okay. Let me also, I didn't really do a good survey to make sure there's no sensitive information in any of my windows. So let me do that for a second. Sometimes you never know when there's like Steam keys for a game in one of the windows. We don't like that. We don't like just flipping to a buffer and giving away 100 copies of a game accidentally. Exit that. All right. Should be good enough. Not to mention language features like constructors and operator overloading kind of imply exceptions? No, they don't. No, they don't. They imply that those things should not fail and that you shouldn't put things that can fail inside those things. Okay, I'm getting my thoughts about libraries in order. Oh, let me pop up. Actually, let me do this on this window because I'm going to need the results over here anyway. So I'll just what? It's in doc. All right, so I'm just going to take these notes and put them here. And you can get the preview of what we're going to do. The other thing to say about people who want exceptions for constructors and stuff is that, we have the context. And so if you want to pass information up your program's stack, you can do that by putting something in the context talking about what happened. And I would claim that if you want to do constructors that can fail, which I think are a bad idea in the first place, but if you want to do that, then you should pass that information up in a way that your application prefers and is in control of. And that method will be different for every application. Also, we might just make it so that the constructor syntax returns additional values, right? I mean, that's not decided yet. And if we do that, then your constructor can just fail and it'll return the failure code as the second return value or whatever. So it's not like any of this is rocket science, is what I'm saying. Does this guy ever interact with chat? Thanks for the 6-month resub, Resonator Games. God, Twitch is terrible sometimes. I don't mean that you're terrible for asking that. I just mean I'm so tired of like the bad chat interactions. Can I super briefly talk about LERP? No. Like why? Everything I have to say about it has already been written. There's a reason why I'm doing this language instead of that language. So I need to do a whole error/exceptions rant sometime, because people are like talking about file not found error in the chat or file not found exception. A file not being found is not an error or an exception, and it's an expected result. Like it's part of the main functionality of your software to do the right thing when a file is not found. So assuming that a file is there is bad software engineering, right? So anything that accesses a file should say on roughly equal terms, here's what to do if it's there, here's what to do if it's not there, right? Similarly with, writing a file. Being out of space is a normal thing. That's not an exception. That's just like what happens on somebody's system, right? So trying to write to a file, oh, we succeeded. Oh, we didn't succeed. Those are on equal terms. It's not like one of them gets shoved in the corner where you don't have to think about it, because then your software is going to break under those conditions because you didn't put the same amount of engineering effort into that as you did your main branch code. So like, these are only a few of the reasons why exceptions are wrong-headed. All right. What about concurrency issues, e.g. the file existed when we looked and then went away out from us during some other process? That is an expected result on a multi-user or multi-process operating system. That is normal. It will happen. So you need to handle that exactly as you handle your main branch code. That's just how things are. Did I design my compiler like that when it reads a file? The compiler opens a file all at once. It reads the entire contents of the file into memory at once. And if a file it's trying to read is not there, that's actually a user error because the user program said to load that file. So we have to correctly report a nice message to the user in that case. So yes, it's totally, that's not an exception. That's the functionality of the compiler, is to tell people correctly when they are trying to load, when their program is trying to load a file that isn't there. I don't know of any good existing examples of program visualization of the kind I'm thinking about, but it doesn't mean there aren't any. It's just I haven't done deep research into it lately. Okay, like I said, I'm going to stop answering questions because I need to get psyched up to do this talk. All right. So let's get started. Today we're going to be talking a little bit about what libraries should be like in this kind of programming language, where this kind of programming language is, well, what is it? It's a statically typed, completely precompiled with no runtime magic, in the style of C or C++, in the kind of programming that you do, but giving you a lot of higher level functionality than either of those languages do, that lets you go up to a very high level while still having control over what your CPU is actually doing. That doesn't try over much to magically manage memory or other resources for you, and that compiles very quickly. I don't know. That neighborhood of programming language, which there's really not that many languages in that neighborhood, but hopefully you have a picture of that. So, over the past couple of years, I've been building out various parts of this language on an as-needed basis. And early on, I did something simple for libraries, quote unquote. And I just said, well, we'll come later. When the rest of the language is fleshed out, we'll come back later and figure this out. And now it's time to figure it out and build something more sophisticated than what's there. I'll review what's actually there today, which is the following. Here's my program. I have a bunch of imports and a bunch of loads. And these only have to happen once in my program, as you'll know if you followed other streams. And import means I'm loading a library, and load means I'm loading a file of my own. There's not that much difference between these. The libraries don't have extensions on them, file extensions right now, just because I thought there might be something to do there with versions or whatever. But it's unclear yet what the actual naming is going to be. Apart from that, import and load are basically the same behind the scenes right now. This only loads one file. If you want to load multiple files, that happens inside the library. So if I go to, if I go here, actually this is not the right, how about input? If I go here to input, it does a bunch of stuff, and it also, oh no, no, what file am I thinking of? Is it basic? Yeah, so this file, it's got a bunch of stuff that applies to every operating system, you know, and then it imports some other things. So if you import basic as a library, it'll also import basic Windows and whatever. So this is better than include in C in a lot of ways. You only ever have to include a thing once, which leads to much faster compile times. But it's really not very sophisticated, and it doesn't do a lot of things that you would want. So let's start talking about what this doesn't really do. Well, actually, before that, so right now, what I'm doing is, let me just go to the modules folder, which is sort of where the libraries live, and there's sort of mostly, you know, one file per library, except, you know, file here, which is a library for loading files. I might load one or the other of these, and so forth. You know, sometimes I break one thing up into multiple. But that's because these libraries so far are relatively small, right? If you want to provide a whole system as a library, you sort of don't want it to be dumped in this folder along with all the other stuff. You want a subfolder, right, containing all the source code for your specific library. And maybe you're loading binary files, right? Maybe you need to link against somebody's C or C++ library, and you're distributing those binaries in the library, right? Or maybe it's a rendering library and you're providing actually some models and textures, and you don't want people to have this extra stupid install step of remembering to copy the default models and textures into their own folder. Maybe you want to supply that in the library, right? So on the one hand, we want to be able to have libraries that consist of many files. Some are text and some are potentially large amounts of binary data, right? On the other hand, I was supposed to say single file, not single fine. On the other hand, for example, the STB libraries in C are really great. Those are libraries that have a large amount of functionality, and they're all packed into one file, and you just include the file and you're done. And that gets around all the horribleness of trying to integrate code into your C program. Here we don't have a lot of that horribleness, but there is still a nice ergonomic benefit to having your library in one file, right? So I would like to have a culture that encourages, if it makes sense, if it's a tractable way to understand and distribute the program, that it should just live in one file, right? And any namespacing that we want to provide in the library should be able to happen by declaring namespaces within that file and so forth, right? But if it's just really large and unwieldy, you should be able to break it into many files, and both should work and both should be handled well, right? And so right now, a single file is fine, but if you get into many files, it starts getting messy. Now, the other thing that happens right now is this is just, these libraries are all living in the modules folder, right? So if I go to my main program, it's the equivalent of user include or whatever, or whatever the equivalent is for your C compiler, where if you include standard.io.h, you get the system standard.io.h. Same thing is happening here, right? If I include, you know, file, I'm getting whatever was installed with the compiler when I ran this, okay? And what I'm going to say about this is actually this is a very bad thing, right? So the problem that you have, especially in the early days of C, but even now, things just behave differently on different operating systems. You know, I call malloc on Windows and I call malloc on Linux, and it behaves differently. And the performance of my program is different for no good reason, you know, and for reasons that are invisible to me because they're buried deep in the system libraries. So that's not very good. The other thing that happens is like, oh, I installed the new version of Visual Studio and it put in a new standard IO.h, and now my program broke and I don't understand why. You know, or maybe it didn't break, but maybe it's running more slowly and so forth, right? So when the compiler is in charge of the majority of your standard libraries, I think that's very bad. So this is part of what I'm saying here when I say very far away from the C++ horribleness. Part of the C++ horribleness is, and this started with C, but it's expanded now, the C++ standards committee believes that a major part of their job is to provide a standard library that does zillions of things. And the reason is because according to them, you can't write a C++ program with things that aren't in the standard library or something, right? Like, if it's not in the standard library, you can't depend on it, or I don't know exactly how they got into the current mindset, but that's their mindset. And I'm going to say, to make a socioeconomic analogy, that's something like the communism of programming language design and libraries, right? It's all centrally controlled. There's a large amount of committee decision in going into what's in that centrally controlled library, and then it's like mass distributed and everybody has it, right? I don't think that's a very good way to do it. I want to have something much more like a capitalism of libraries, where what the compiler provides is, well, let's not say what the compiler provides, because I want, when you install the compiler, to have access to libraries that like render graphics and open windows and do all this great stuff. But in terms of the C-like model, where the compiler is loading stuff that is installed specifically on your operating system and might be different on another operating system, I want that to be tiny, like 100 lines or less, right? Like that piece should be as small as possible. And what we should be trying to do is let there be an ecosystem of people making libraries, and you can use whichever one that you want. Now the problem with that starts to sound like NPM or something, right? Where there's all sorts of people making libraries, and whichever ones get trendy right now and that you hear about, because there's so many things that it's kind of like a hit movie or a hit game where like you use it because you heard about it, not necessarily because it's good. But well, there's multiple dimensions of NPM horribleness. One of them is that these things will change behind your back or suddenly become uninstalled or whatever, right? So that's bad too. So what I want to do is a version, well, let me just say, in the game industry, when we're shipping large games, we're very concerned with being able to build the game the same way across many operating systems, or build the same source code across many operating systems and many different kinds of hardware, right? It needs to work on a game console and a phone and a PC, right? So what have we learned about that? What we've learned is that if you want to be able to build, and not only on those platforms today, but like 5 years from now, if you want a chance for that to work well, what you do is you check in all your dependencies into your source tree, right? So if you're using free type to render fonts, which we do, we did that both in Braid and the Witness and now in the Sokoban game. If you're using free type, you don't just like install whatever free type is current on the Linux machine that you're building this game on right now. No, you find exactly free type version x.y.z. You check that source into the support folder of your source tree so that you can rebuild from exactly that source anytime you want. And then you precompile binaries for all the platforms that you intend to hit, so you can reuse those binaries exactly anytime you want. And then you have stability, right? So it's exactly the opposite of what the open source people think is like the right culture. At certain sectors of the open source people, the open source people who sort of decided, you know, like how keeping your Linux machine up to date should work and stuff is just like, oh, fuck it, just install the newest whatever. That doesn't work. The people who understand reproducibility better are sort of the branch of those, of the open source people who are doing containerization now, right? Like those are the people who understand like, oh, you want a reproducible environment. You want to deploy exactly a specific thing and know what you're deploying and be able to use it, right? So the problem with containerization is it's ridiculous because it's doing all this work to just get back to what we used to have in the 70s when you only had to, your only choice was to statically link your binary against its dependencies, right? So I'm not going to rant about containerization right now, but we'll just say that for using libraries, I want the model to be something like that, where let's say there's some equivalent of a package manager where you can search for libraries on the internet, and you're like, I want to get, I've heard that the Foozle window opening library is really cool. I want to use that. So let's install that on my machine, right? So what'll happen is you'll download that, and as soon as you import it in your game, it's going to copy it into a libraries folder of your program, right? Not a system folder, but a libraries folder of your program that you're expected to check in source control, right? Your program won't build without warnings probably if that's not there. And that provides reproducibility. Now that's a little bit inconvenient for small programs probably if you're making like a one file program. So we might, we need to tune the features so that it works best, right? If you don't have any subfolders at all and you just want to compile one source file, then like creating this giant subfolder is annoying. But for like programs on the scale of what I do most of the time, it's exactly the right thing. Now, I don't know of many languages that do that. Somebody told me that Go seems to do that, but I haven't actually programmed non-trivial things in Go, so I don't actually know. But that's sort of the plan, is that you use a specific version of a library, and you would specify that by version in, you would, well, we need to work out a few specific issues. So if I say import math, right, this probably means if I haven't installed math in my local dependencies yet, it probably means get the newest version, right? But then once this is in my local dependencies, it means get that one that's in my local dependencies. Now, the interesting question comes of what happens when you pull in 4 different math libraries because different people needed different versions. And, which one does this mean? And we probably actually would designate it by which file requested it or something. That's a thing that needs to be worked out, right? Now, if you say something like that, then you're obviously asking for a very specific version. Now, I think that the compiler should probably be integrated enough with a system for getting code that you can just do this, and when you run this for the first time, it'll pull this down and put it in your program's local dependencies, right? But unlike NPM, you will never go to the network again to get this thing after the first time. And in fact, it'll give you a nice big fat warning the first time that it happens, like, okay, we're going to the network, we're copying this over. This should only happen once, blah, 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 right? Because the whole NPM thing of your resources are accessed over the network is just, it's a ticking time bomb. It's thousands of ticking time bombs like wrapped in one, and it's really pernicious and nasty. So that's my initial thought. Now, of course, none of these things that I'm saying are tested by reality yet, right? I'm just saying what I think is the right way to do it, and we'll go from there. So now one of the things that I mentioned is, what happens if you pull in 3 or 4 libraries that all want different versions of math, right? And it might be that, my 3D GUI library uses a certain version of math because that's what they tested it with, but I want to use a newer version, and I, as the person distributing the program, am taking upon myself the responsibility that I'm requiring it to work with a newer version, and I'm going to deal with any problems that come up, right? So you want the author of the actual main program to have ultimate control over any of these things, which means, for example, if a library says it needs math 3.1.1 and I want 3.4.5, I should be able to override it somehow without editing the source code of that module. And I'm not sure in what way that will happen, but there should be some convenient way for doing that. It shouldn't be a big deal, right? Like, and the reason I say without editing the source code is, you know, you want, for at least maybe for security or just for peace of mind, it would be nice to have your imports folder be read-only after a certain point, right? So you can't write new stuff to it, so that you know that stuff's not changing behind your back unless it's just hard drive bit rot or something. Or, you know, you should be able to pull it off a network share that you don't have write access to. And so you need to be able to have control over these things without doing that. Of course, you could do a trivial thing where you load in the file as a string and do a string replace on the import, but that's really ugly, and we should come up with something better than that. Now, another thing that might often happen is you have multiple libraries that want the same thing. This is sort of another reason why you might want to remap somebody's dependency. Like, one guy says, I'll use the newest version of zlib, and another guy says, well, I'll use, you know, this specific version. Like, say you want to load zip files and you want to read ogg-vorbis files. Both of those want zlib, like a lot of people want zlib. So the main program needs to be able to negotiate somehow. Either we're going to have many copies of zlib, maybe that's fine, or maybe we want to minimize that to reduce our compile time and to reduce our binary size and so forth. And in that case, you know, you want the main program to be able to negotiate this. It's not exactly a conflict, but negotiate the redundancy and to make something good happen there. All right. Now, a thing that will happen that's not really a redundancy or a conflict is that many people, you know, may want to namespace a particular library as whatever name they want, right? That shouldn't require you to reinstantiate the library for every module that wants to use it as a different name or something, right? So that's pretty obvious. I don't think that's rocket science, and I don't think that, I mean, certainly there are languages that do that wrong, like C++, right? In C++, the source file namespaces itself so that you are not in control of that name, and it may conflict with something else that you want and so forth, right? But it's not that hard. Lots of languages do it better than C++. It's not hard to look around and find people who do it better, right? So that's not that scary. The interesting thing is this global scope question, right? So right now, well, let's talk about what it might look like if you're namespacing, right? I might say import math. Right now, what happens if you import math is it dumps everything from math, or whatever math exports goes into your global scope, and math is parented under your global scope. So when it looks up identifiers, it goes all the way to the root, and so it can see the identifiers of your main program. And one thing that's a little bit nice about that is a library could say, well, you just have to declare something called foo, and we're going to call your foo routine. And if you just don't declare that, then the program won't compile, right? It's a very low technology way to interface with a library, but sometimes you might want that, right? Or maybe you say import math as new math or something, and then you say, you know, new math.cosine or whatever, and this should be familiar with you. Lots of languages do that. I don't know if this would be the exact syntax, but it's what we're talking about, right? And then some other file might like import math as my math library. And like I'm saying, both of these names should work, and they shouldn't cause any redundancies or inefficiencies, right? Now, the The thing about the way it happens right now, where every library can see up to the root of the program, is there's a subtlety that you might not think about, which is that overloads may change. And because our compilation model is different than C++, this matters, right? Well, it matters in C++. So in C, your library was probably precompiled into an object file or a lib or a DLL or SO file, right? And so overloads, for example, are already resolved. If you call some function foo, it already decided what foo is, right? You can't accidentally override that. But our compilation model is different. Everybody compiles at the same time when you hit the build key, and everybody compiles fresh every time. And what that means is if you use a library and it can see up to your root, it can see your declarations of procedures that may happen to coincide with its names, right? And so you could, in theory, change the result of an overload operation in a way that the library didn't want and that you didn't want, and that would be confusing, right? So if somebody passes a U16 to a bar function that takes a signed 32-bit number, and you make bar of U16 in the root of your program, and you didn't know that they used a thing called bar internally, but now your bar is a better fit than their bar, and that's going to result in confusion, right? So my thought right now is that libraries probably can't see your program scope at all. Like, they have their own root, so the sort of the top level of your program is a bunch of roots, and nobody can see anything outside. Except there's sort of a super root where compiler-specific things are defined that everybody can see. I think that's probably the best way for it to work, but I'll be interested in comments that people have about that. Should modules have parameters like some languages do? Like, especially functional languages, you would say, so let's, for example, let's not do math. Let's do something like, do we have window creation? I guess I must load it in a different file, but let's say I was doing like import window creation, right? Or how about this? Profiler. Say I have a graphical profiler, right? And I'm just going to import it as the profiler, just to change its name. Say this is a graphical profiler, and it draws graphics on the screen. Well, maybe it has a way for me to provide it a way to draw graphics. Or maybe even before that, maybe there's just, maybe it has an enum that it declares that says, well, you could do OpenGL, you could do Metal, or you could do software rendering pixel by pixel. Which one do you want? And maybe I want like software rendering, right? So are there module parameters, and how do they work? Already this is a little bit weird because this is like an enum declared by the profiler, and I don't have access to it until after it's instantiated, but I need to use it before it's instantiated. So what's the deal with that, right? Maybe it just has to be a string or a constant, right? Like software, because there's no such paradox there. So that's one slightly annoying problem. Or maybe to get around that paradox, libraries can say, well, here's a set of things that get evaluated before we have parameter instantiations, and here's a thing after. I don't know. So that's an interesting, it's an interesting question how that works. And then once you have parameters, you have a more complex negotiation to do, because now instead of just people using different versions of the math library or something, they might use it with different parameters. And now, are there some cases, like maybe my profiler is has a text mode or a graphical mode, and the first parameter is, do you want graphics, right? And I can say false, and if I don't want graphics, then we just don't build half the code, and its compile time is faster and executable size is smaller and all that, right? But maybe another module that I'm loading says, hey, we want to import profiler, and we want to draw it with software rendering, right? So actually, we want this to be true. So you could end up instantiating this library twice because it has different parameters, which may or may not be what you actually want, depending on what the library does and what the main program wants it to do. So again here, I think maybe this is a place for the main program to resolve this negotiation. Like, okay, well this guy wants false, no graphics, but no graphics is a subset of with graphics, and so we're just going to do this one and point this guy at that. And like, how do we do that in a way that's not a giant train wreck disaster is an interesting question. So we might, for this kind of reason, we might not do module parameters until later. I don't know. Usually, the kind of languages that have module parameters are functional languages that don't care about efficiency or shipping real software anyway, so I haven't seen that many satisfactory resolutions to this kind of problem, but I haven't looked lately, and I certainly do not have an encyclopedic knowledge of what all the functional languages are doing. So if anybody wants to point me at something interesting there, that would be good. This is not that important to talk about. This is a minor variation on the global scope thing that we already said. Okay. Namespace management, right? In addition to being able to put a library into a specific namespace, right? So we just said, you know, let's just go back to this simple case and ignore parameters, right? I might want the profiler. Let's use an example I was talking to Ignacio about, right? So I'm just going to import print as print, or maybe importing it as the same name over here is the default. It's fine, it doesn't matter, right? And I make a thing called a vector3, right? Or maybe this comes from someone else's library. And I is the main program. Yeah, let's say this came from a library that's even read-only and I can't edit the file or have no desire to edit the file. I want to tell print how to print the vector3. And I want to set that up once globally at compile time, right? Because I want my vector3 to be formatted nicely. I don't want to use the generic struct print. So how do I do that? Well, one way to do it is I could just say, I could make something called print vector3, right? Like something like this, and whatever, do the printing. So once I define that procedure, the thing is, how do I tell print about it? Well, you could say print has a compile time metaprogram that scans my program for things that have a type signature that lets me print it, right? But the problem is, maybe I have many things in my program that take these, but one of these is for serializing to a binary file, and the other one is for text files, and I don't want print to pick the wrong one, and so forth, right? So, you know, you could come up with some naming convention, but that's kind of hacky and weird. And anyway, we sort of just said, certainly we don't want print when it's calling its own routines to be able to see your global namespace in that way, in the like overload kind of way. So, and if it was browsing your whole global scope, that might be really slow. So what might you do? Well, maybe print has a sub namespace that's automatically there. Maybe there's a namespace called like print.print routines or something, right? Or it's called print dot because I imported as print. And maybe I can say the following thing, like print.print routines. I'm just making ridiculous punctuation. Maybe that gets print vector3, right? And I'm jamming this into that namespace at compile time, right? So I'm pushing a thing. I think something like that for communicating with libraries is a good thing, right? I mean, another way that you might set up print routines is you might do it at initialization time in your program, like early on in main. You might say, here's a set of all the print routines But then you have to collect that information out of libraries and centralize it, and it's a pain in the ass. So I feel like you do want it to be a compile time namespace operation, and then print can look in its print routines namespace, which is a much smaller thing and cleaner thing to iterate over. And there will be no mistakes, right? If I have other procedures that take these same kinds of arguments, I just won't poke those into this namespace, and then print won't get confused about what it should use. So I'm thinking that that may be how that works, but maybe there's a better way to do it. So I think those are the main issues that I wanted to cover in terms of what I'm thinking about today. So now we can go into a more general discussion mode and collecting ideas from people. I'm going to take a 5-minute voice break because my voice is getting a little ratty, and I'll get some tea, and then we'll come back in a minute. So a 5-minute break. Get questions and comments ready in the chat. And when I come back, there might be lots of discussion in the chat. So if you put, @ and then my name, I'll see them more clearly. All right. So 5-minute break, and then we'll get to this. All right, well, maybe it's less than 5-minute break. I feel ready to talk about this stuff. Whoa, a bunch of things. Oh boy, okay. I'll start up here. You mentioned when talking about the print example that this linking would happen at compile time. How would you use an already compiled library? Is that even supported? You would do it the same way that we link with OpenGL or something like that. You certainly can do that. We need to do that to communicate with other programming languages, right? So if you want to call into C or C++ code or anything like that, it's going to be in a precompiled library. So yes, that is supported. But in terms, I talked at the beginning a lot about setting a culture, right? The culture of this language is that libraries are not, for the most part, precompiled if they're in this language. And the reason why you don't want that is because if it's precompiled, you kill a great deal of your power and functionality over the code. And you introduce all sorts of caching bugs and just a lot of the inconveniences that make C and C++ programming very annoying. So the plan is that we just make the compiler fast and you don't worry about it. And if programs eventually become big enough that it takes a long enough time to compile them that we're worried about that, then I think we would just have the compiler do local caching that you don't have to think about. So it'll group every 20 files into one aggregate file somehow and only rebuild the ones that it needs to. But then you wouldn't have to manage like precompiled groups of things. Of course, if you want to, you can always do that because your compile time metaprogram can do whatever it wants. So you could build things into a library and then link that. It's just, I don't encourage that. I don't want that to be the standard thing that happens because I think that compilation model causes a large number of problems. It's also slow. So, yeah. What size of libraries are you thinking of when building support? I assume it isn't going to be awful 100 lines of code libraries like on C's in systems like NPM. Well, like I said, it's going to be kind of like the capitalism of libraries. So I'm not going to prevent somebody from publishing a 100-line library. I think that's pretty dumb. There are very few things that are important that are 100 lines long, although there are some. Like you could write an A-star algorithm in under 100 lines. However, if you did that, I think a friendly version of that library would include some sample code and like some programs that would draw graphically the results of the algorithm so you could understand that, right? So a good version of the library that really helps people use it might be substantially larger than 100 lines. It might be thousands of lines, even though the core nugget is 100 lines. So certainly I don't want there to be like left pad kinds of things. Yeah. Do you think forcing everything to have a namespace would make things simpler, better? I'm already confused about global and super global, what silently overwrites what. Yeah, how would I explain? The way I'm thinking about it currently is that probably everything goes into its own namespace by default. And then if you want to dump something into your global namespace, you do a using on it, right? So you would do, So right now, if you say import font, well, okay, here's an interesting question. Right now, if you say import font, it dumps all the public functions and data members of font into your global namespace, right? I'm thinking that after this change, it dumps them into a sub namespace called font, and then you might say using font if you want the old behavior to dump everything in. However, you almost always don't mind it or kind of want some of a library's methods to get into your global namespace, right? So maybe actually, maybe there's some namespace called font.exports, right? That font defined, and these things automatically get usinged when I use the library, right? Or something like that. And then I can say even, without exports, if I don't want that behavior to happen by default or something like that. I don't know. These things are undecided, and so I'm interested in just hearing what people have to say. How do I envision setting up where the libraries are grabbed from if you don't have them already? Is that a compile time metaprogramming setting somehow? Well, so I would expect that we run a server somewhere that the compiler already knows about when it's installed. So it's just, some host name that we maintain, and that would probably be in the build options, right? So we already have in this compiler module, we have this thing called build options, where you say, hey, am I building an executable or a library? Is it debug or release? This is outdated, but is array mounts checking on, right? And based on what backend, like if it's the LLVM backend, we have a ton of other options about, what kinds of optimizations are allowed and so forth, right? So I think in here you would just say, primary module server hostname is, in fact, it doesn't even have to be compiled into the compiler. It can be right here in this file. It could just say, foozle.flathead.org, right? And primary module server port is 69105, right? And then maybe there's a secondary, right? I don't know, right? So actually you can't have port 69,000, can you? Is it only 16-bit? I forget. Anyway, I think the highest port is like 32K minus 1 or something like that. I don't remember. Anyway, that would be, where this comes from. And then if you want to set it to a different server, you could set it, right? Or maybe it's an array of servers instead of just being 2. I don't know. But, something like that you could picture. Why not support importing file hashes and then have the compiler try to find a file with the matching hash? That way you can start a load library once and store it in app data subfolder, and multiple projects can use it without creating copies or cluttering source control. No. Okay. So what he's saying is, well, hey, if you only download a library once, everyone can use it and so forth. And what I'm saying is, no, that is not right. That is not what you want for robustness and reproducibility. You want no dependencies between anything mysterious and anything else. So you want the source to the libraries in the source tree of the specific program that you are going to compile and distribute and archive as a unit. If you're going to store this program as a unit in cold storage somewhere on your archive machine and pull it out again 5 years later, it's not going to have the same operating system level app folder that you had 5 years ago, and you're not going to have those particular libraries that are downloaded. And if you download different copies now, who's to say they're exactly the same? You can hope they're exactly the same, but maybe they're not. Maybe it's like NPM and one of them got deleted and now you're out of luck. No, it's not the right solution, right? It's easy to think that it's wasteful to store a copy of this in every program. It's really not. Text files are small, dude. So now I did say that large binary files might come into play, but I don't think you link a massive library with large binary files into everything. I think that's a rare thing. So it's really the right way to do it, to have a separate copy for every program, for sure. In earlier demos, you showed the functionality of prefixing library namespaces for named access. Is that still a thing, or will it be changed to something else? I think that'll still be a thing, but it won't be on load anymore. It'll just be on using or something like that, right? So when I say using on the library, I can add the name remapper there, and that'll change the names as they come into my namespace, right? The reason it's on load right now is that load kind of does a using of its own, or import does a using of its own. And if we take that away, then you do an explicit using. While using compile time metaprogram to discover print functions sounds like an incredibly flexible tool for library writers, Wouldn't this specific case be better served by traits or some trait-like functionality? First of all, what do you mean by traits? Because lots of different programming languages have a thing called traits, and they're all different from each other. And and they're all different from each other. So what do you mean, first of all, by traits? Secondly, I hate the word trait because it doesn't mean anything. It's like such an abstract word that it doesn't tell you anything, right? What's that? Oh, it's a trait. Okay. Thirdly, if whichever programming language's concept of traits you're talking about requires you to declare the trait like in the struct that it's a trait of, then that's not what we want to do, right? Because again, we want to be able to create print routines, or that's just the example, of course, but we want to be able to create print routines for somebody else's code that we don't have write access to, right? So that's what we're talking about. I think libs should default to separate isolated roots. The programmer can optionally grant access to namespaces. The programmer can also optionally inject their own code into the library. Yeah, I think that's kind of what my default impression is right now. But we'll see. You know, I kind of want to just collect everyone's opinion. Regarding the module parameter paradox, doesn't the dependency system in the compiler already handle this? The library author just can't create a circular dependency. No, it's not. Let me explain better maybe what that paradox is with a different thing that can't be resolved the same way, right? So before we were talking about, like, you know, import profiler, right, as profiler, you know, false. We did this, right? Whatever. So that's a thing where the main program can negotiate this by saying, okay, these are actually the same library, right? Here's one that doesn't work that way. One library says import math as math, and we want 32-bit floats, or, you know, let's call it vector math, right? Someone else has a totally different name, and they want 64-bit floats. And let's just say that, you know, vector math makes, you know, it's like its declaration of vector 3 is vector 3 is a struct of float type is a type, and it's x, y, z of float type, right? I mean, maybe I would capitalize that, I don't know, right? So now we have two different libraries who are instantiating modules with different parameters, but they are not compatible, right? The version of all the functions that you compile using vector 3 of float 32 is going to be different from all the functions that take vector 3 of float 64. And you can't just merge them. You just have to say, well, we do need to instantiate and compile this library twice. Whereas in this version, you don't. Do you see what I'm saying is the difference there? So it's not something, I don't know, maybe we could discover some way by which the compiler could figure this out automatically, but I'm very suspicious of that. I think it's something that the main program has to do. If it wants to, right? By default, we could just compile this as two different libraries, and there you go. It's just that that's not very good in the general case, because a lot of people might import print, and I don't want to have 27 different versions of print. So that's the thing that we have to figure out. C++ namespaces, why not? Because they're terrible. From the way I interpret libraries, couldn't there be like a default library translation that runs just before load? I should answer the C++ question more thoroughly. I feel like I already said it, and if you don't understand what I said, I don't know what else to say. The problem is that you say, so in C++, you have this thing where you say, you know, namespace, whatever, here, and then you put a bunch of code in there, and then you close the namespace, right? The problem is this has to be done inside one file. Like, if I write a library, I'm namespacing the library because I have to know what that namespace is, because otherwise my code won't work, right? Especially if I have some code outside the namespace and some inside the namespace or whatever, right? Now, you might think in C++, oh, well, you'll just do this. Maybe we want the program to be able to namespace the thing. So I, as the application author, I want to call this thing whatever, but then I'm going to import, sorry, C++, I'm going to include, you know, some library, right, .h, and I'm even going to include the CPP file because we want to namespace all this in here. Well, this is screwed. This will break. Like, it just won't work, right? So C++ is just, it's backwards, right? And so then the problem is, say I made a math library and I'm like namespace math, and I named it. Well, maybe somebody else made a math library and called it math. And now I can't link both of these into the same program. So, yeah. Oh boy, I'm so behind in the chat. Guys, I'm scrolling off the top of the chat. So I missed some questions. How to manage different version of a same library. For example, Vorbis needs zlib 1.7, whereas you want to use zlib 1.8. Well, that's what I was saying is, I think it's up to the program author to decide that, right? It might be that Vorbis just tested with zlib 1.7, and that's what they warrant will work. But maybe you happen to know it'll work with 1.8 because you tried it. Or maybe you fixed a couple of problems and it's fine. Or maybe you just don't call the one routine that breaks in 1.8 and it's fine, right? So I think that's a thing that the main program can decide somehow, right? Maybe. It might just be a mess. I mean, we might try to make some negotiation mechanism and it just is too messy and ugly and horrible to use and it's not worth it. I don't know. It's just the idea that I have about that. TypeScript has import XYZ from library. Yeah, I mean, it's a common thing, for sure. What is your current opinion about what should happen when two imported namespaces are imported with the same name? If you just join them, maybe you just declare print vector3 to be in print routines namespace. No, I think by default, if you try to import two namespaces as the same name, that's just a hard error, right? Maybe there's a merge operation. Like maybe I can say import print, or let's say pool as mempool merge, and I'm merging that with something else also called mempool, but that's usually not something you want to do to someone else's library. Like that's going to make a mess, right? You really only want to do that maybe if you're dealing with bundles of exports and you want to put a couple of export namespaces together, right? I do think that probably some kind of merge operation makes sense, yes. But I think what exactly you want that merge operation to do depends on what you want to do. So maybe when you say merge like that, you also provide a function that resolves name conflicts. Like what if you're trying to merge this namespace and there's two identifiers that are the same? Well, by default, that's probably an error. I mean, unless they're overloads of a procedure, but if they're just like variables, that's an error. But then maybe you want to supply a procedure that says which one to discard and which one to keep or rename and so forth. Someone says, Yolia does that export identifiers, but you can still access all the other stuff by library name .not exported thing. Seems reasonable. Yeah, I think something like that. In general, functional languages do a much better job of namespace management than imperative languages. I'm not quite sure why, but they just do. So, yeah. Oh, 65K max port. All right. Importing file hashes means that only a file that is exactly byte for byte identical to the one you had will match the import. Yes, but that only solves half the problem. What about the problem when you can't find the file anymore? What do you do then? As the compiler organizes its own compilation directly, it will be interesting to embed fully the source. For example, using a URL import. Here, X would mean any and latest. I don't want URL imports. No. That's exactly what I'm talking about is the problem in NPM, is that you're fetching. You don't want to fetch your dependencies over the network, like ever, right? That's just a bad thing. So there might be a library that gets things from the network, that fetches them, but you don't describe those by URL because that's just a bad habit. It encourages bad things. And you know, if you're used to that culture, I'm just including a thing off NPM or GitHub or something, it might seem weird, but that's a very bad culture, I'm convinced. It's an anti-engineering culture because engineering is about understanding what's going on. Maybe some basic system libraries directive for very small programs. Yeah, maybe. I mean, yeah, maybe there's a directive or a build option where you just say, like, don't do the library copying thing. I think that's fine. When I talk about the library copying and all that, I'm more thinking about solving the problems that large programs have, right? Small programs don't really have that many problems because we've just figured out how to do that over the decades. But large programs, not very many people are working on making the life of a large application programmer easier. At least not in non-dumb ways. Like, you know, Visual Studio has all sorts of weird stuff built in, but none of it is actually what you want. Maybe have a file that comes with every library in which the author can customize what happens when the lib gets imported. For example, it could list all needed files, metadata about the author, and other dependencies of the lib. Yeah, maybe. I don't think that would have to be a specific file. I think it could be a directive anywhere that you want in the file, but yeah, maybe something like that. Joe Sweeney says, I think that single download could work if you keep track of a hash of the file. No, the exact same file is only a subset of the problem, guys. I mean, I realize you asked that before I said that last time because we're so far scrolled back in the comments. But no, the real problem is I don't want to have to worry about re-getting all my dependencies in a year or 2 years or 5 years. Or tomorrow when my hard drive eats itself and I need to reinstall my machine. Would there be any feature to allow extracting internal declarations that are under file scope out from a library? Yeah, I believe that should be there. Like whatever the namespace operations that you have. Right now there's almost nothing in the way of namespace operations. The only one there is using, which is like pull everything in this namespace out. But really you want pull out, put in, remap, merge. I mean, split is just make new namespaces and pull things out selectively. But yeah, I think you want to be able to reach into file scope of files, for sure. It's not something you want to do commonly. It's maybe a little bit ugly if you do that. But if you're trying to ship a program and you need to do something, you should be able to do it. So yeah, absolutely. In the case where a vulnerability, bug, etc. is found in a library, how would you let the lib writer put out a fix and notify the user. It would be nice to at least give a warning in the compiler saying something like version 131 of the known vulnerability, 132 fixes the problem. Or even say something like, we don't have a fix yet, we're working on it, go to URL for more info. That's not a bad idea. I kind of like that. Like your compile time, so in general, we've put forth the paradigm that your compile time metaprogram can have a full custom set of code auditing or code inspection routines, maybe that you don't even run all the time, because maybe you want the build to be as fast as possible usually, but maybe once a day or once a week you run these things. Maybe they only get run by your continuous integration server and it sends you, grumpy output about things you did wrong. But stuff like this could definitely be in there, right? Like, hey, once a day we check the package server to see if there's any new warnings or anything, and we tell you about them, and then your code auditor looks for those dependencies. That would be good. Why should the main program not be allowed to add functions into a library's types? I don't know what you mean by into a library's types. You mean like adding them to a struct? Is this a traits question? What is this? Because again, I don't know what people meant by traits before. But if you poke things onto a struct, then you're definitely going to affect introspection of that struct, right? And maybe that'll do something bad. If you add an actual data member, maybe somebody's unserializing that struct from the file, and now there's an extra data member that ain't in the file, and that's the problem. You've got to think about these things. Can it not be explicit, e.g. my math float64 would run math.module main float64? But we're not talking about what you run. We're talking about what you compile in the first place, right? In order to run I guess I'm not quite sure I understand the question, but it doesn't matter exactly how it happens. What matters is the end result, is that you need a 32-bit math library and separately a 64-bit math library, because different people want to use different things. So, whereas it's a different situation in the profiler case, you only need one. So that's all I'm trying to say there. Something like import override print. Yeah, I guess. Sometimes with short questions like this, if I read them 20 minutes after I gave the answer, I don't exactly know what in a nuanced way it was referring to. So maybe since there's so much of a backlog, you need to put a little more context into the question. Couldn't functional polymorphism solve the vector math problem you highlighted? The vector has a constructor that determines the type of the struct. That way the type decisions of the program happen at runtime. No. Okay. This is a fully compiled language, right? We don't want to make decisions about types at runtime because that's slow. And it requires runtime type annotation. So if you're saying that vector has an additional member on it that tells you whether it's a 32 or 64-bit vector, and then you call some length function, and that looks at the type tag and calls length 32 or length 64, that's not the kind of language that this is. If you like that kind of language, that's all right, but that's not what we're building. What we're building is something where everything is determined at compile time. So when you call length on a vector, the culture, obviously you can build a library that does anything, but the culture is that for a basic math operation like that, you have decided or the compiler has decided at compile time exactly what procedure is being called. It's already compiled, it's already in machine code in the output program, right? So we're not doing foo-foo softy stuff. And it's especially not like Java where you like JIT a routine while you're running. We don't do that, no. Re-module parameter paradox. Sorry I wasn't specific. I agree that the main program probably needs to be the broker between modules instantiated with different parameters, perhaps an event pulled by the metaprogram. The paradox I was referring to was using a type defined by the library to parameterize the library itself, e.g. profiler software renderer. Oh, that one, right, okay. The current dependency system should handle this. No, not strictly speaking. The current dependency system does not handle that. I mean, unless, like you could separate things out so that it does handle that, but it just wouldn't happen magically. Like that engineering would have to be put into the programming language. The reason is because if that enum is defined by the module and we can't start compiling the module until we know its parameters, then we don't know what the enum is. Even though you would think that as a human being, by looking there, you could see that it's constant and so forth. We don't, if you think of a module as being basically like a big struct, especially if it's parameterized, we don't start compiling the body of the struct until you give us the parameters, right? And so you can't really use a parameter of the struct that you haven't compiled yet. You would have to declare the parameter as something outside the struct and then do that, right? Which is fine. It's just we would have to have a way to say that so that you don't have to import two modules for every module that has parameters, and one of the modules only provides the parameter values. You know what I'm saying? When you say you want all libraries in a modules folder or whatever, and I'm assuming that will include the ultra basic stuff like print and file, yes. So maybe I wasn't clear on that point, but everything like print, file, compiler probably, I'm not sure about that one, random, like almost everything that's in, you know, standard whatever .h and C gets capitalisticized instead of communized, right? The model back in the 70s with C was that most of these includes might have to do highly operating system dependent things, and so you want every operating system to define those. But in the modern day, code is not that OS specific, and when it is, it just does something like an if-def in the file to control what's happening. So if I have a rendering library and it wants to be different on Linux versus Windows, like our GL library does, then we can just have a small amount of code in the library that switches off, but it's the same source code, and so what happens there doesn't have to change on the different operating systems, right? You compile the same library source on both operating systems, it just knows how to adapt itself to each one. That wasn't the end of the question. That was my interjection in the middle of the question. So he goes on to ask, or say, I do feel like it's valuable to still be able to use the print and file stuff while also opting out of a modules folder handed to you, since you might be just scribbling and you just don't want a big folder structure. Yeah, that's what I was saying about, for a small program, you probably can override this stuff. But I think if you're shipping a substantially sized application, that this is what you want. And so it's going to be seriously built into how the compiler works. Right? That's all I'm saying. You might have hinted at a solution to the question of parameterized modules with your exports example. Give it many instantiated param sets, but lib can continue to be loaded once, period. Internally, the lib calls would always access only whichever param set is relevant for a given call site. I'm not sure I understand what enemy mouse is saying. I don't think I understand what you're saying. Maybe if you could say that in a different way, I just don't. The question is, what code do we generate, right? It's not, you said libcalls would access only whatever param set. I don't know what you mean by only accessing a parameter set. That's not, we're talking about generating substantially different code for different parameters at compile time. So it's not a question of what the library has access to, it's a question of what the library is. Is the library boundary problem related to how Go handles interfaces, or a procedure implemented for vector3 implicitly satisfies an interface defined in print? I don't know. I mean, I don't do enough Go to exactly know the answer to that question. But the question is not, so my understanding of Go interfaces doesn't really solve this problem. Because the problem is just, how do I declare a priori without having to specify at runtime? How do I declare in my program text how to print things? And I actually don't know what people do for that in Go, if there is such a way to do that or not. Saying like, oh, here's a thing with an interface of a printable that I can pass to the print function at runtime, that's not the problem. We can do that too. That's no big deal. The question is, how do I let all my libraries declare how to print all their things with me having the ability to override that and whatever without having to do a lot of runtime collection and marshalling, if that makes sense. What happens if one of the imports contains the variable? Casey, you know that's never going to happen because nobody has ever localized the variable. The Heisenberg uncertainty principle ensures that this will remain further beyond the grasp of our current technology. Tyler says, Python lets you import specific functions or classes from a module and rename them to something else if you want, like import range, make a rando, which can be kind of useful if you just one or two of the functions out of a module. Yeah, totally. I think you definitely want that ability for sure. You actually almost already have that. It's like that's basically a selective using. We have a mass using, and so actually no, you already have that because you can import. And you can have a renamer that just throws away most of the routines. It's not a very syntactically elegant way to do it, and we'll probably make a better way. But yeah, totally, I think that's the kind of thing we want. Engineering is about understanding what's going on, yeah. What about on importing a new library? We give it information about which other libraries with what parameters are imported so they can negotiate between themselves. But the thing is, I don't think that the different libraries can negotiate between themselves. I think, well, I mean, maybe I can provide a hint, right? Maybe I can say, I want math 1.7, but that's because I only tested 1.7 and maybe newer is okay, but I don't know. That could be just a hint, like a standard hint that you provide. But I don't think you want to completely automate that because, again, I think only the person writing the main program understands what needs to happen. It's just not something like that's intent, and intent comes from the programmer of the application. It doesn't just materialize out of throwing things in a bag and mixing it up, you know what I'm saying? Am I going to allow two different libraries include different versions of the same library? Absolutely, you have to, for sure. You have to, because if I'm using FreeType to render stuff, and I don't want to have to upgrade FreeType, and that version of FreeType only uses this really old zlib, but I also want a newer zlib because it's faster for loading my game assets, I need to be able to do that, absolutely. And not only do I need to be able to do it, it should be easy and simple. Is it possible that parameterized imports don't provide sufficient value versus alternatives? Dead code elimination, exports, overwrites from main program, compile time metaprogram, split into multi-loads, etc. It is possible, yes. It is possible that any good solution to parameterized modules is more complicated than just doing it a low-tech way. And so I don't want to presuppose that we have to have module parameters. It's just an idea that seems like it's quite possible to be an answer, and so I felt like I needed to bring it up, for sure. It would be really nice if you can specify source control repos as a place where your project looks for libraries. Yeah, probably. I mean, I don't know. The thing is, it depends. I don't know. We have to see. It depends a lot on what does it mean. I mean, no matter what, there can be a library that does that, right? And the question is if that's built into the compiler. I don't really like the culture of we grab our software from random places on the internet. Like, it's just a little too fly-by-night. That's all. But sometimes you know exactly what you want to do. But you know, what's wrong with just downloading that? Like, if the model is anyway that we don't fetch things off the internet every time, it's only the very first time when you build your program, then what's wrong with doing it the way we do it in C++ right now and just downloading it? That works fine, right? So I don't think the compiler needs to resolve URLs. But maybe I'm wrong. I don't know. I would love a section for breaking changes between versions, making it less scary to fetch a new version or easy to find the update path. Good culture. A section for breaking changes between versions. You mean when you declare a library? I don't know. I don't think you mean just documentation, right? You mean like some kind of code? I'm not sure I understand. With the run module main case, I mean the library itself can resolve the situation. The function could return the same namespace, a different one, or just fail. No, my point is the library doesn't know. The library does not know. If one part of your program uses the float32 version and another part uses the float64 version, and maybe both of them can use the float64 version. Maybe they can't. Maybe it's absolutely impossible. The library itself that's being used doesn't know. It can't know because let me put it this way. The reason a library is a library, right? It's code reuse. And you want your code to be reused by a lot of people in a lot of contexts because that's what makes it useful. Letting your code be reused in a lot of contexts means that you don't know when and where and how it's being used and for what purpose, because you're making it as reusable as possible so all kinds of people will reuse it for all kinds of purposes. So therefore, you as a library author cannot assume too much about how people intend to use it. Otherwise, you drastically restrict people's ability to use it, right? This is a fine point of library design, but good people who are good at making APIs understand this very thoroughly. And so you can't have the library itself resolve these conflicts because, again, these are conflicts of the intent of the designer of the application as a whole, which is much more complex than the library by itself. And the library by itself doesn't even know what the main program is supposed to do. It doesn't know if it's a video game or telemetry for a satellite. It has no idea. So it just can't make these decisions. Will the tentative module init function be a compile time function? Well, I don't know. I mean, your modules can certainly run things at compile time just like your main program. So there's no lack of abilities to do compile time things. Module init function? Do you mean like the equivalent of like DLL main for a module or something? I mean, you can't, the thing is you can't do everything at compile time. Sometimes you need stuff to happen at runtime. So, I don't know, right? Anything you can do at compile time, you could just do in a run directive. I was thinking of module parameters like globals that the user of the library gets to set. It seems like it wouldn't take much work to get this working, since you can already set files in a different file. Are you thinking of any module parameter use cases for which this doesn't work? I don't know, that's a very general question. And I'm not sure, again, I'm not sure I understand. Module parameters like globals that the user of the library gets to set. The thing is, globals, if they're just global variables that are, well, if they're variables, then you can't do anything at compile time, right? If they're global constants that you get to set, then, you know, you can have static ifs, making choices on those and so forth. What you really want is things that are you want to be able to polymorph the library's data structures and stuff like that based on the parameter values. That's what they're for. And so, yeah, they could be essentially globals of the module, right? They're not necessarily globals of your main program, but they could be globals of the module. That part of the implementation, I think, doesn't matter that much. The paradox that I stated before was not even a paradox. It wasn't a paradox about what the parameter's value was. It was a paradox about declaring and using what the potential values for the parameter could possibly be in the first place. But yeah, they could essentially be like globals of the module. Sorry, I was not clear in the question. Do you plan to somehow embed an importer version controller within the compiler, or let the user manually manage it externally? For example, import mylib where version is greater than 174, or import or it's greater than is equal to 17x. I'm not sure what the best way is to do this, but I don't think it's a good idea to just say magically re-get any newer version than 174 every time I compile. That's not good, right? It might be, hey, import mylib without a version, and the first time we compiled that was 174, and now we've cached 174, but maybe we can run a command that reports to me if there's anything newer if I want to upgrade, right? But it shouldn't magically upgrade it. That's horrible. Horrible. PUBG. I might do PUBG. I got a new computer today, according to Jeff's specs. I haven't installed everything on it, and I haven't downloaded PUBG, so I'd have to be playing PUBG on my old computer. Could happen. Casey got his first chicken dinner on Sunday-ish. Was that a group or squad chicken dinner or solo? Enemy Mouse says, I was not thinking properly about the compiled code in my suggestion. You understood my meaning, though, and I don't know the compiled equivalent of my suggestion beyond generating multiple versions of specific areas, i.e. defines, and the compiler managing the right paths to call, depending on the parameters which apply to the client call site outside the lib. I mean, the other thing is, the thing I said about not understanding what the main program wants to do actually goes in both directions, right? The system also doesn't understand what the library wants to do internally. That's the whole point of an abstraction barrier, is that you don't want to have to think about what's going on behind that barrier unless you have to. If someone wrote a really fast Fourier transform, you don't want to have to be an expert in the Fourier transform to understand why it's fast. You just want to know that it's fast so that you could use it, right? So for that reason, if a module has parameters, then I don't want to have to think about what the module's doing with those parameters, right? I just want to know that I supply them and it does whatever it needs to make things happen. And so there's kind of a, in both directions, one party doesn't know the other party's intent and shouldn't need to know. With a little bit of a caveat that if you're forced to reason about the intent, like I need to resolve for efficiency or general conflict purposes, I need to resolve the fact that these multiple libraries are trying to be used, then you have to understand the module's intent, but you want to keep that limited, right? It would be nice if there was a good way to patch some part of the library if there was a bug in the library, particularly after you library freeze and the bug fix from the original author contains new features. Yeah, well, one reason why I'm saying you could copy it, or that it's copied by default into your source, is like you just make another copy and edit it, right? Like if, in C right now, if I wanted to patch something in user includes standard.io.h, that is heavily discouraged, right? It is really not something that that would normally happen. But why not? You know, especially, well, right now, why not? It's a very rare thing for that to happen because the code for standard.io is not actually in standard.io.h. It's in a precompiled thing. But imagine that for this language, the culture is shifted so that all of the code is in standard.io.h. Now, you might well want to patch that, and it might make you more powerful as a programmer than you are typically because these things are locked away in precompiled binaries, right? So you want to have that power. And so if instead of living in some read-only system folder where every program you compile is going to use that same file, it's much more hackable if it's just a subfolder of my program and I'm just going to copy it and I'm going to try out this other version for a bit and I'll switch back to the main one if my hack doesn't work or something, you know. I think that would be nice. Module parameters feel like a more flexible version of C++'s defines, but I think you should be able to customize more extensively than just parameters to one function. What about something more like how build options works? But I mean, build options is like, that's what module parameters are. Like the module has to define its own version of the build options because the programming language doesn't know what the module wants. And so you could fill out its build options and pass it to the module for sure. But the point is you have to be able to do that at compile time for the module to configure its code correctly. You can't do it at runtime. That's all. But yeah, it could be like build options, but that's just module parameters. It's just one of them happens to be a struct instead of like an enum or an integer or a type. Why are there so many people with message deleteds? What's going on in chat? What if it was easy to specify that you only want the original members and functions when looking at the type info for serialization? That would allow safely adding members and functions to structs in libraries, which is common in many languages and very useful. Is it useful? And like, what's it useful for? Because we certainly could do that. Like, or even we could have a flag on members of a struct that says, hey, this member was defined by the actual module, or this was added by somebody else. But that's more complexity that you have to deal with at runtime. And who knows what that means? Maybe I actually serialized it with that other member on it, right? And then, I don't know, like, it's more complexity. And so that complexity has to pay off. And sometimes people say things are really useful, and I ask them why, and they just say things that I don't actually think are useful, right? Or that are already, you know, like people say, oh, exceptions are useful for passing error information up your program. And I'm like, no, they're not. They're not. Stop pretending they are. So, you know, I've used quite a number of languages that are soft and fluffy like that, that let you change all sorts of things. I've made languages like that. And what happens is you end up with lots of cryptic errors that you can't figure out why they're happening when you start doing that. And so not only is this language statically typed, but I want there to be a certain hardness to it. Like, for example, even though there's lots of compile time metaprogramming configuration, you can't change the syntax of the base language. I could have done that. I could have said like, oh, now you can make it reverse Polish notation or something. But that's just confusing, and it doesn't help that much. You know, the technical burden incurred by those features is much heavier than what you get for having them, right? And so hardness is worth a lot. That's what I've learned in my decades of programming. I started out at Berkeley, you know, well, I mean, I programmed BASIC and assembly language at home in high school and grade school, and those are not hardened at all. And then at college, my first language was Scheme, which is not hardened at all. And, you know, Lisp in AI classes and stuff. And then I eventually learned C and stuff like that, but it took a while before I learned statically typed programming. And as my career has gotten longer and I get more experience building bigger and more complex things, I gravitate ever further toward that hardness because it's worth a tremendous amount. Because not being confused about what the fuck your program is doing is worth its weight in gold. And that's just a feeling that you don't have in Lisp or Forth or assembly language or BASIC, right? So I lean in that direction. And that's not only static typing of, you know, procedures and variable types and stuff like that, but it's other things as well. Like, what is this struct? I don't think it's a good idea to go in and mess with a library struct unless that library wants you to, right? Why? Well, because it's less confusing. It's more clear. And yes, you could maybe make some contrived example where you want to do that, but you can probably do this, reach the same ends in a different way that doesn't create as many bad habits, right? That's what I think. That said, the whole reason we're having this talk is that maybe somebody will say, how do you do this specific thing? And I'll be like, oh, that seems really important, and I don't have a way to do that. But I would need, to be convinced of that, I would need something much more specific than, oh, this is useful in general. Like, we need to say how it's useful, and how it's useful in a way that can't be done better or as well or 90% as well by other things, and where those other things don't incur problems at least as large, right? Everything's trade-offs, and you have to actually analyze, you have to do the cost-benefit analysis on these things. On specifying additional repos to look for libraries, just give an example. At my current work, the code depends on 3 libs from 3 repos inside my company, and when I want to change the version of a lib, I just have to change one line in the configuration. Having to download the whole thing would be cumbersome, and I might make mistakes while doing it. Yeah, totally. No, but you're saying specifying where the libs come from, but you're talking about a paradigm. You're talking about a paradigm where you're downloading the libraries all the time. And what I'm saying is we don't do that here, right? What I'm saying is if you wanted to have 3 libs that you switch between, what you would do is you would install those 3 libs into your program's library dependencies, and they live in your source tree, and then you just switch between the 3 libraries locally, right? You don't switch between them as things that you get from a server. That's just not the culture that we're building. Now, you might say, but those libraries are under development from the company, and so we need to get those all the time. But then they should just be in a source tree that you're updating by other means, right? Because they're under active development. So, like, active development is different from I'm using something that somebody exported as a fixed version of a library and warranted to some degree that it's usable by outside parties, right? Tyler says, why not just have a special version of import that makes it always request its most recent version, like import and update, because I think that's a bad idea. I mean, you could do that. Maybe we'll do that and just say, I don't recommend that. Because the problem is 10 years from now, your program won't compile. And you'll be like, God damn it, why won't my program compile? Oh, because it updated this library to a newer thing, and I haven't made it work with the newer thing. James Widman says, this all sounds pretty good. Yeah, I think so. The thing is, there's definitely unsolved problems, but I don't know if they're going to be hard to solve. I think we just kind of have to see. Definitely, I don't know if putting the putting the library into your local source tree might be cumbersome. It might be error prone in some way. I don't exactly know. We have to find exactly the nuances that make that that make that work as effectively as possible. Squad chicken dinner, all right, man. Did you cover letting the libraries themselves handle the import negotiation? I think I did. Maybe it was after you asked that question, because I'm again going through backlog. How about a way to describe which library versions are compatible with another library? Because the libraries don't know. They don't know. They don't know what you're going to use them with. They know what they want to use, but they don't know what you will use them with. Megaton when? Later, man. We're working on getting the library or the compiler usable by external parties, and Megaton probably comes after that. Someone's asking, what would be the alternative to throwing exceptions? Dude, I've ranted about this many times. Somebody could probably link you one of the rants. I'd rather use compile time metaprogramming to patch and extend libraries by replacing methods, adding members, and fixing problems in most cases instead of editing a copy of the source code and merging changes from upstream when updating. Well, you say that now, but the problem is compile time metaprogramming is also a way of merging changes, right? Except when the merge fails, it's going to be more confusing because it's an algorithm that's failing instead of text that's failing. So I don't know. I mean, what you're saying, it might, I mean, I don't want to just say no to your answer because it might be in the long run that that's better. We've never tried it in this language, and I don't know of any language that's really done that thoroughly at the scale of software that I work on. So maybe it's true, it's just I'm skeptical, right? I'm trying to have a very realist approach to metaprogramming because some people get so excited about metaprogramming. They're like, metaprogramming is the future and it solves all our problems because going meta is always better. And it's like, actually no, because going meta is confusing, right? The more meta you get, the harder it is for your brain to understand what's going on. There's extreme value to concrete, simple text files that just say what's going to happen, and then that thing happens, right? So I'm trying to keep, when I build the example programs and stuff, I'm trying to keep a culture of simplicity, right? Where if we do things in a meta program, it's because they're things that you can't do at a simpler level, like audit your code. That has to be a meta program. But something like I wanted to, this one vector handling routine didn't use intrinsics for ARM, and I want to put that in because it's faster. I would probably do that kind of thing by copying the library, honestly. Maybe not. I don't know. We have to see. We have to see. That hardness talk warms my hearth. Yeah, something. It seems like the hardness solution for many imports of a lib with different module parameters is generate the whole lib for each unique param set. Even without params, a lib can already do a static random thing, so each import already has to deal with that, right? Yeah, I think by default that's true, and that's probably the correct approach given no other information. The thing is, I feel like there's going to be cases where you want to be able to merge them, right? But by default, they probably just are separate compilations, right? And if I did the profiler thing that I showed, like this one, probably by default, that's two separate builds of the same library. And then if I take steps to go in and make them one build, then it becomes one build. But by default, it's probably two, for sure. When you do import, does it always prefer the one in the current directory or from the compiler dir? Can you override in any direction? What I'm thinking is that it goes into the compiler directory, and that is the only one you see from then on, right? And in fact, you probably need to run the compiler with a certain command line option to even get it to copy over. It'll probably fail to compile until you do that option, like -install or whatever. Something like that. Why can't you auto-fetch libraries is quickly becoming the new exceptions are good? Yeah, maybe. A guy in this chat already said exceptions are good, so whatever. Yeah, I was talking about active parallel development, not something stable that I get once. Yeah, so I do think those are different cases. So for active parallel development, that's a thing, like if something is in active development in your own company, then you probably have your own way that you like to do things, and you just want to be free to make it work however you want, however is most convenient for you, right? So in that kind of a case, I think the job of the language is to give you options and stay out of your way and not demand that you do things any specific way, right? But for the other case of you're using things that somebody else produced for you to use. We still want to let you do whatever you want, but the default way that things will go should be whatever we design to be the most robust. That's what I think. What about if your company is working on two games? You have a shared library code between the two games. One of the team added some functionality to the library code, and the other team wants it now. Should they pull in changes from the first team and patch their library code, or should they pull in the new version of the library from a central repository? Well, that's what I was saying about active parallel development, right? The answer to that question, I can't say, because it depends on many things. It depends on what that library looks like. How thorough are the changes? How easy are they to merge? How important is it to jump to the new version of the library as opposed to keeping the old one? Different people have different solutions to this, right? So many game companies, let's say in the early to mid 2000s, would internally fork their own library and then manually copy over changes or whatever, because they wanted this compilation robustness. But some companies did it differently. So for example, Harmonix, around the time of the later Guitar Hero games and early Rock bands, they just had shared libraries on local company servers that they would, that they would maintain, and they'd maintain both the libraries and the programs so that they all were current all the time. I don't know if they changed that approach later, but they did it that way. But lots of people would not want to do it that way. As a software development house, part of what makes you a skilled development team is that you make the right call on issues like that for your area. And so that's what I'm saying about the language needing to get out of the way. It needs to provide you options, but get out of the way in that kind of a case. Because you know what's best, right? Don't let people load remotely. They can write a metaprogram. Well, that's totally true, right? So if you load a frickin' thing off GitHub and somebody's GitHub account got attacked and somebody inserted a run directive in there, that run directive can erase your hard drive, right? That said, that's also true for regular open source today. Like makefiles are Turing complete. If you download a thing and run make in it in an automated script, that could erase your hard drive as well, obviously. So it's just a bad idea generally, though. I missed the earlier part of this talk, but did you talk at all about how to handle situations? We have a large complicated program that needs dynamically loadable plugins, which might want to share a lot of code with the host. No, so like plugin dynamic library kind of stuff is a little bit of a different issue from what we're talking about right now. And I'm not even sure that that's a language level issue. That might just be like a library level issue or application level issue. I'm not sure though. You can email, by the way, for any of this stuff, if you have questions, comments, whatever, you can email to this address that is not a mailing list. I read everything that goes there. I don't necessarily reply to many of the things because my time is limited, but if you want to communicate ideas in ways that are too nuanced for Twitch chat, or you just think of something later, then go ahead and email me there. Metaprogramming is the future and it solves all our problems. Well, I know Casey thinks that. I know Casey thinks that, but I don't think that. I think metaprogramming is super powerful for sure. But I think you should not go meta without good reason. Because I like concrete and simple, right? This is also why I don't think much. Like when I was in college, I used to think continuations were super awesome, and all this functional language like meta things were super awesome, and that was because they were neat ideas that I hadn't been exposed to. And it's like, whoa, you could like call a function and never return, and that could be, the function could be defined as the result of what your program would be if you ran it till the end. That's like a trippy concept, right? But it's like, it doesn't really solve any problems except for the problems that functional languages created for themselves. So they're not problems that imperative languages have, and then it's just ideas that are being meta just to be meta, and that's fine, but it makes your program more complicated, and complication creates problems. Or if not more complicated, more abstract, and abstraction creates problems because abstraction is usually harder to understand than concreteness, given the same information density, right? If you can, the good abstractions are when you can make an abstraction and I don't have to understand what's on the other side of the abstraction, right? That's the good kind. But if you make an abstraction, but I have to understand just as much about it as I had to understand in the concrete case, then the concrete case is a much better program. Why not just throw an exception if the fetched library version conflicts with your current code? Yeah, thanks, Tyler. I'll get right on Don't forget to make sure it's we're in the sarcastic comments time because we've been going for like 2 hours. Reorder of type checking of code. It seems like you want to complete all type checking semantic analysis of an imported library at the point of the import before trying to do any type checking on the code that contains the import. That I think is true. I mean, you can't really do any type checking if you haven't fully determined what the type of the imported things are, right? But that's something that I think is already handled by the dependency system in the program. I don't anticipate new problems there, but maybe I'm just not having enough foresight. I don't know. On local versus compiler folder imports, then you need to look out for foo/bar instead of importing foo/math instead of global or local math. That was hell in Python for years. So you mean importing a file that is meant to be part of my own program source versus a library that happens to have the same name? I think that's just different directives. Like right now we have load for your own files and import for externally provided files. And I think that that's what resolves it, if I understand your point. You know, like I said at the beginning, load and import aren't that different right now, but the point is that they will be more different later, and that there should not be confusion between them. Maybe all the smarts you need to merge is to ask the program to provide a mapping of the libs they want to merge, so they can even merge subsets of the lib and provide an auto mapper that writes a skeleton that maps it all and lets the implementer customize it. Yeah, maybe. Frankly, it's a new enough idea, and I've mostly been solving, you know, much pickier problems that I haven't thought that much about what the solutions to that might be. So that might be the way to do it. Honestly, you have probably thought slightly more about it than me so far at this point. My intent is to think more about it, of course, but yeah. Why did someone paste a page-long Facebook link? What the hell is going on? It's a GameSpot link on Facebook. All right, it's a PUBG link. Great. Embrace the power. I feel like we're mostly done with questions. With a directive to modify a function in a library, the compiler could cache the code of the library function source that if you updated the library and the function changed, it could output a diff of the change to allow you to back the change is still valid. Yeah, maybe. I mean, here's the thing. I totally buy that that might work and might be the best way to do it. At some point, so, you know, one of the things I'm doing designing this language is I'm putting in the features that I've always wanted to have, or that I think would be the most powerful features, right? So that's good. Here's the trick, though. The level of language that's implemented today, even before this library stuff, has these features. And so by definition, I'm not as experienced in those features as I am in C++, right? I've been using C++ for 20 years. I've been using this language for 2 years or less, and often not full time, right? Because I'm, you know, doing other stuff. So I just have to say on this kind of issue, I don't have a clear picture of what is going to happen when you try to do that for metaprogramming. And I think it probably takes years to build that picture. And for me to be able to say, oh yes, I think this is the right way, or no, it's not. Which is kind of what I'm saying about staying out of the way, first of all, but also there being like a capitalism of libraries, and us, and that my job being to make it easy for you to get to whatever code you want to use it, as opposed to supplying a standard library that you must use, right? So I think if somebody wants to build the system that lets you kind of monkey patch things that way, it might be the best way to do it. It totally might be. I don't know. If a library author did not separate the platform-specific code, you imported another platform, what sort of error message should you get? You're just going to get an error message that something is not declared, right? But that's like, that's the library author's job. So the ideal library, in some sense, has no platform-specific code, but as you get performance-oriented, you probably will. And so then it's the library author's job, probably at the head of the library, to have a compile time assertion that says, hey, we're supported on this operating system, or no, we're not. And they should say clearly that they're not supported on this operating system. Or maybe, hey, we run on this operating system, but we don't have a fast path, so you're getting a slower version of the library than you might otherwise, but we'll run, you know. That's just part of making a good library, I think. What comes next after the library stream? I don't know, man. We're just getting it ready to ship. Would it be possible to procedurally generate libraries modules with string parameters and then merge the procedurally generated libraries, or essentially have the library be a meta program that generates function structs? Yeah, totally. You can do that today. Before we even do any of this new stuff, you can already do that. It's fine. What is the length of your current language email backlog? 0, because I don't have to reply to most of it. I've read everything. Well, unless someone sent me stuff during this presentation, I've read everything. All right. Deep neural network to learn how to merge by merging with itself. I'll get right on that. There's other people working on it. Yeah, we have 3 people working on this now. All right, I've been talking for way too long, so I'm going to sign off here. Thanks for coming by and leaving your comments. And again, if you want to leave lengthier comments, or you wake up in the middle of the night with an idea, you can send it to this email address. This actual work on the new library system probably will happen in pieces and won't start for at least a couple of weeks because I've got other things I need to do. But, you know, sometime soon. The reason why I wanted to have this chat now is because it's becoming time to think about this so we can make it happen. So thanks everybody for coming by. If you missed part of this, it'll be posted on YouTube and so on and so forth. And I'll see you later.